Hi everyone, welcome to the channel. Today we are kicking off a brand new series on Amazon EKS, that's Elastic Kubernetes Service for those who are just starting out. In the first video, we are going to create an EKS cluster manually from the AWS console. Now I know a lot of people jump straight into using Terraform or CloudFormation, and that's great once you are already understand how things work. But the problem is those tools skip the fundamentals. You end up deploying everything in few commands without really understanding and knowing what's happening behind the scenes. So in this video, we'll go step by step through the manual process. By the end, you'll clearly understand how all the pieces of EKS fit together. The cluster, the node groups, the IAM roles, networking, and whatnot. So once you've got that fundamental solid, in the future videos of this series, we'll dive into automating all of it using CloudFormation. So if you're ready, let's get started. So I've created a GitHub repository where I've mentioned all the instructions and all the commands which we will be using in this series. And this is the very first folder or the directory which you need to open, which is called 00 create folder. And I have mentioned all the instructions which we will be following in this video. So just open this, and the very first thing that you need to do when creating an EKS cluster is you need to create a VPC. Alright, so let's head over to the AWS console, and I'll head over to VPC here. I'll open the VPC. By the way, I'm going to create my cluster in the Mumbai region. So you can choose your region accordingly, depending on the place where you are and the region which is supported. So right now I have a VPC here, which is the main VPC, but we are not going to create our cluster in the main VPC. Rather, we'll create a new VPC for our EKS cluster. So let's head over to the GitHub repository and let's start. Create a VPC with /16 slider range. By the way, before we proceed, let me show you the architecture diagram so that it's easy for you to visualize it. So this is what we will be creating first. This is my VPC, inside which I'll have two public subnets and two private subnets. And in this public subnet, I'll have a NAT gateway, and my EKS worker nodes will use this NAT gateway to reach the internet. Apart from this, I'll also have an internet gateway here for my public subnets. And once this is done, I'll launch an EC2 instance and I'll install kubectl, EKSCTL, and then I'll try to connect to my EKS which are deployed in our private subnets. So if that sounds interesting, let's get started. So first of all, let's create a VPC with /16 slider range. I'll just copy the slider along with the IP address range. I'll click on create VPC, and for the name I'll just give it name EKS VPC, and this is going to be my IPv4 slider range. I'm not going to use IPv6 slider range and tenancy. I'll leave it as default, and I'll just click on create VPC. Okay, so my VPC is created. You can see here now I have two VPCs in AP South 1. Let's go to the next part. Create an internet gateway and attach to the VPC. All right. So now I'll create an internet gateway for my VPC. Right now I have one internet gateway which belongs to my main VPC. I'll just head over. I'll give it a name like EKS VPC internet gateway. Tags are already added for us, and I'll just click on create internet gateway. By the way, in case you're not aware, let me just tell you, you can attach only one internet gateway to a VPC, and you can see it you can see it here. The moment I click on it and I'll try to attach to a VPC, I'll get only one option, which is the VPC that we just created. It's not giving me an option to attach it to the main VPC. The reason being clear, the main VPC already has an internet gateway attached to it. So I'll just select this VPC and I'll click on attach internet gateway. So now my internet gateway is attached to my VPC. Let's see what we need to do next. Create two public subnets and add the following sliders. And don't forget to add this tag. I'll tell you why this tag is used. So whenever you create an application load balancer, whenever we'll be creating an ingress for our EKS cluster, these tags will really be helpful. But in this video, we are not going to be creating any ingress. But still, as a best practice, we'll add these tags there. So let's head over to the subnets. So right now I have 4 subnets here, and all of them belong to the main VPC, as you can see here. Let's click on create subnets, select the VPC, and I'll select my EKS VPC. Let's give it a name. The first is going to be EKS VPC public subnet 1, and availability zone I'll select AP South 1A, and for the IPv4 slider range, I think I've mentioned it here, so I'll just copy this. I'll paste it here, and don't forget to add the text which I have mentioned here. and the value is going to be 1. I'll add one more subnet. I'll give it a name, EKS VPC. I'll follow the same naming convention so it's easy for us. Public subnet 2. For the AZ, I'll select AP South 1B, and for the CIDR range, I'll copy the second CIDR range which is mentioned here. Alright, I'll add the tag again. And the value is going to be 1 here. I'll just click on create subnets, and now 2 subnets are created in our EKS VPC. This is the VPC name, by the way, and they are named public subnet 1 and public subnet 2. Now let's move to the next part, which is to create 2 private subnets. I'll again head over to subnets, click on create subnets. I'll select our VPC. I'll name it EKS VPC private subnet 1. For the AZ, I'll select AP South 1A, and for the CIDR range, I'll choose the one which is mentioned here. We'll add the tags as well. I'll click on add new subnet so that I can add second subnet as well. I'm going to name it private subnet 2. For the AZ, I'll go with AP South 1B, and for the CIDR range, I'll just copy the one which is mentioned here again. I'll add the tags. And I'll click on create subnets. Alright, just give it a refresh. Just remove these filters from here and apply a new filter which is going to the VPC name so that we can see how many subnets do we have in this VPC. And as you can see, we have 4 VPCs. 2 of them are public and 2 of them are private. Let's move to the next part. Make sure the internet gateway is attached to the VPC we created earlier. So we have already done this part in the second step. Let's move to the next part, which is to create a NAT gateway in one of the public subnets, and this is what we are going to be do. Let's move to the next part, which is to create a NAT gateway in one of the public subnets, and this is what we are going to be doing now. So we'll just click on NAT gateways, click on create NAT gateway. I'll name it EKS VPC EKS. It doesn't matter because we are going to create it in the public subnet. So, but still, let's name it EKS Internet Gateway. The subnets, select one of the public subnets from your VPC. I'll select public subnet 1. Connectivity type, keep it as public. No need, just click on allocate elastic IP, so that AWS will allocate an elastic IP from its IP ranges. And no need to add any tags here. If you want, you can add it, but there's nothing which is mandatory here. Click on create NAT gateway. Alright, so our NAT gateway is created. Just wait for a few seconds before it comes into the active state. Meanwhile, we can move to the next part. Create a public route table and a private route table. Alright, go to the route tables, and right now you'll have 2 or 3 route tables, and let me just show you what they are. 2 of them belong to the main VPC which was already there, and 1 was created with our EKS VPC. So whenever you create a VPC, a main route table is created with it, but I'm not going to use that, so I'll click on create route table. I'll name it public route table. Select a VPC, and I'll select EKS VPC. I'll click on create route table. Alright, so our route table is created. Now I'll create one more route table for our private subnets. Private route table. I think I forgot to prepend it with EKS so that it's easy for us to distinguish it from the other route tables. Select the route tables. I'll select EKS VPC and I'll click on create route table. So now we have two of our route tables in place. Let me rename this so it's easy for us to identify this. Okay, so now we have EKS public route table and EKS private route table, and both of them belong to our EKS VPC. Let's see what we need to do next. Add the following route to the public route table. Okay, I'll open my public route table from here and I'll add a new route. Add a route to the internet through the internet gateway. Okay, click on add route. For the destination, select 0.0.0.0/0 and the traffic should go through the internet gateway. I'll select the EKS VPC internet gateway and click on save changes. Alright, so this part is done. Now add the following route to the private route table. Now I'll head over to the private route table, which is this one. Click on edit routes, add routes, and I'll again select the same slider range. And this time, instead of using the internet gateway, I'll use NAT gateway. I'll select the NAT gateway which we created and click on save changes. So this part is done as well. Let's move to the next part. Associate the public route table with the public subnets and private route table with the private subnets. This is a crucial part because if you don't associate the route tables to the subnets, they're going to use the main route table. I will select the public route table and I'll head over to subnet associations, and right now you can see there are no subnet associated explicitly. Click on edit subnet associations and select the, just a second, I think I forgot which route table it is. It's a public route table, so I need to associate public subnets with this. Click on edit subnet association, public subnet 1 and public subnet 2. Both of them are associated with this route table. Now you can see it here. I'll do the same thing for the private route table. Click on edit subnet associations, EKS VPC private subnet 2, EKS private subnet 1. Click on save associations, and now both of our subnets are associated. So we are done with the VPC part. We have created this entire infrastructure here. Now we can head over to our EKS console and start creating the EKS cluster. So, but before that, we'll need an IAM role for that. So let's head over to the IAM. Click on roles, create an IAM policy EKS cluster trusted policy.json. This is only required when you are creating the IAM role using a CLI command, but I'm not going to use a CLI command. I'm going to do everything from the console. So instead of doing this, I'll just click on create role. I'll keep it as AWS service, and here I'll select EKS. I think this is what we need, eks.amazonaws.com. Keep it as EKS cluster. Go to next. Assign AWS managed permission policy. So this policy is needed to be attached. Okay, so I think it's already there. Click on next, and you can see the trust policy. It is exactly the same as the one which is mentioned here. Okay, let's give it a name, EKS cluster role. I'm using Pascal case, but you can use camel case or whatever you like. Click on create role. Alright, so our role is created. I can just copy and paste it and see that role here. So this is the role which we just created, and this is the trust relationship. It allows EKS to perform operations in our account. The next part is to create the cluster using the documentation. So I'll just click here and open this link in a new tab, and here you can follow the instructions line by line. Now let's finally head over to the EKS. Click on create cluster, select custom configuration. Alright, and disable this EKS auto mode. I'll tell you what EKS auto mode is in the future videos, but for now just keep it as disabled. For the cluster name, let's follow the documentation word by word and line by line. You can see it here as well. You need to disable the EKS auto mode. Let's give it a name. I'll give it as prod cluster. For the IAM role, select the IAM role which you created, which is this EKS cluster role. Kubernetes version settings, I'll keep it as 1.31. Upgrade policy, keep it as standard. Allow cluster administrator access. Make sure this is selected. So what it does is, it allows you to assign yourself as the administrator of the cluster. And when I say you, it basically means the entity which created this EKS cluster. So right now I'm logged in as Titan user. So I'll have all the permissions to manage this EKS cluster. And cluster authentication mode, keep it as EKS API. Don't use EKS API in config map because it's kind of old and nobody uses it anymore. Use your own EKS node, just don't select this part. We do not need ARC, zonal shift. I'll explain everything, what all these things are in the future videos, but for now just keep it as they are. Head over to the next part, specify networking. Now this is a crucial part. Here you need to select the VPC which we just created, EKS VPC, and for the subnets we'll select the private subnets because we want our EKS cluster to be in a private subnet. Alright, so subnets are selected. For the security group, optional. So whenever you create an EKS cluster, EKS automatically creates a security group for you. So you don't want to create one, but still, if in case you need additional security, you can create a security group. I'll just skip this part and it's anyways optional. Choose cluster IP address family. I'll go with IPv4. Don't do anything here. AWS EKS will take care of this. For the cluster endpoint access, this is a very important part. Let me explain it to you. So whenever you set your cluster endpoint access to public, it means your Kube API server can be accessed from anywhere. Alright, as long as the users are authenticated, they can access your API server. And if you select private, you can only access your Kube API server from inside the VPC where your EKS cluster is created. And the public and private, it's kind of a hybrid mode where you can access the cluster from public as well as private. But we are going to create a secure EKS cluster, that's why I'll keep it as private. I'll go to the next part. We do not need this right now. I don't need any audit logs. Go to the next. Just select the add-ons which are already there. I'll tell you what add-ons are in the future videos, but for now just keep them as default. Don't modify anything here. Go to the next part. Configure. So this part is done. Now you just need to review your EKS cluster and click on create. Alright everyone, so our EKS cluster is created. You can see here the status is in active state, and now if you see here, I've got a notification and it says provision compute capacity for your cluster by adding a managed node group or creating a Fargate profile. So what does it basically means? So when you create a EKS cluster, it creates the control plane for you, which means it will have all the master nodes, but you need to add worker nodes there for the clusters to work properly. So if you go to this compute tab here, you will see there are no node groups or there are no nodes present in my EKS cluster. So let's head over to our GitHub repository and create node groups. So you have to go to this directory called 01 manage node groups AWS console.md and follow the instructions line by line. So it says follow the documentation to create a role using managed console. So I'll open this link here, and it says creating an Amazon EKS node IAM role. I've done this quite a few times in the past, so I'll just directly create it. You can read the instructions just in case you're doing it for the first time. I'll head over to the IAM and I'll open it in a new console. Go to the roles, click on create role and select the trust entity type as AWS service, and here select EC2 because worker nodes are basically EC2 instances. Go to the next part, and now comes the main part, which is the permission policies. So whenever you create a node group, you need to assign them proper permissions so that they can join to the EKS cluster. If you mess this part, your worker nodes might not add to the EKS. So I have listed all the policies which you require to add there. So first of them is Amazon EKS worker node policy. just go here and paste it here. It's AWS managed policy, so you'll definitely get it. And the next one is EC2 container registry read only. I'll add this one as well. The third one is Amazon EKS CNI policy. And the last one is going to be Amazon SSM managed instance code. So this policy is used to SSH into your EC2 instances using SSM agent. Select this and go to the next part. Give it a name. I'll name it EKS node role. Everything seems fine to me. I'll just click on create role. Alright, so our node role is created and you can verify it by just copying it. Alright, so our node role is created. I'll search for the role here. And this is the role that we just created. Let's go to the next part and see what we need to do next. Create the node groups in the private subnets. Alright, so now I'll go to the compute section. In the node groups, I'll click on add. I'll give it a name, EKS node group. And for the node role, I'll select the role that we just created. I don't want to use any launch template. Kubernetes labels, we are not going to be using any Kubernetes labels, and neither we are going to use any taints here. For the AMI type, it will be automatically selected depending on your region, so you don't need to mess with it for now. EC2 instance type, keep it as T3 medium. For disk size, keep it as default, which is going to be 20 GB, and for the desired size, minimum size and maximum size, keep it as is. Maximum unavailable, we'll keep most of the values here as default, no need to mess with anything here. For the subnets, you can see it automatically selected the private subnets which we created in our VPC, which is a good thing. So click on next, review and click on create. Alright, so node group creation is in progress. It might take several minutes for the EKS node groups to be created. Meanwhile, what we'll do is we'll create a EC2 instance and try to connect to our EKS cluster, which is shown in this diagram here. So this is the EC2 instance. We'll create it in one of the public subnets so we can connect to it, and then we'll use this EC2 to connect to our EKS cluster. So which is shown in this diagram here. So this is the EC2 instance. We'll create it in one of the public subnets so we can connect to it, and then we'll use this EC2 to connect to our EKS cluster. So let's head over to the EC2 part. Meanwhile, this is also mentioned in the documentation. So create an EC2 instance in the same VPC as your EKS cluster. Click on launch instances. Let's give it a name like kubectl server, because that's what it will be used for. Keep the AMI as is. Instance type, it can be T2 micro, there's nothing wrong with it. For the key pair name, I'll just proceed without a key pair, because I'll connect to it using the EC2 default direct connect or SSM manager. For the network settings, make sure it's created in the same VPC as your EKS cluster, which is going to be EKS VPC, and the subnet should be the public subnet. Otherwise, we won't be able to connect to this instance. So I'll select public subnet 1. I'll select one of the existing security group, which is going to be the default one, or you can select the EKS cluster security group. One more thing that you need to take care of is the instance profile. I'll use the same instance profile which I used for the node because it has that SSM permission, if you remember. Click on launch instance, and our instance is created successfully. Let's try to connect to the instance. It might take a few minutes for the SSM manager to be in a ready state. Okay, it says no public IPv4 or IPv6 address was assigned. Let me just spin up. I think I kind of messed with it, so I'll just go to the instance again. I'll go to the instance setting, Let's go to the network part. Or we can do one thing, we can just create a new instance instead of just modifying it. So I'll just click on instance state and I'll delete this instance for now. Click on launch instance, kubectl instance, keep the EMI as is, keep the instance type as is as well. For the key pair, we do not need any key pair, and the VPC should be EKS VPC. Subnet should be the public subnet. Auto assign public IP, enable this part so that we can connect to the instance using direct connect. Select existing security group. I'll just select both of them. No need to mess with this advanced network configuration. And one more thing that you need to do is add the node role. Click on launch instance. Alright, so our instance is created again. Let's click on connect to the instance. Now I'm getting this option to connect to it. Let's try to connect to this. Just wait for a few seconds so that it's in a ready state. Alright, so I'm still not able to connect to my EC2 instance. Let's go to the instance and see what could be the error here. So if you remember, when I created the instance, I selected the default security group. Here is the default security group. Let me just open it. And if you see here, it doesn't have any port opened here, and we need port 22 to SSH into an instance. So I'll click on add role. I'll select SSH, which is going to be port 22, and for the traffic I'll just select 0.0.0.0, which means you can connect to this instance from anywhere. Now I'll give it a refresh again, and boom, I'm connected to the instance. Let's do ls and see. Okay, everything's fine. Let's head to the documentation part again, and now we need to run this script here so that we can install kubectl, helm, EKSCTL, and other tools which are required to connect to the instance. So I'll just copy this. I'll create a new script here which is going to be install.sh, and I'll paste it here. I'll change the mode, and I will just run this file. It says permission denied. Okay, let me run it as sudo. Alright, so now our script is running. We just need to wait for a few seconds before all the tools get installed there. Meanwhile, we can go to our EKS console and see the status of our node groups. Alright, so our node groups are created, and we have two nodes which are in ready state. Let me just open the cluster again, go to the compute, and you will see our node group is ready. And you can verify the same from the EC2 console as well. If you go to the EC2 console and go to the instances here, you will see, just give it a refresh here, and you will see two T2 medium instances are created here. Okay, let's see. Alright, so the script execution is completed. Let's see if kubectl is installed here. Kubectl, and it says kubectl not found. Alright, I think the kubectl is not installed here due to some reason, or maybe I'll just switch to sudo. So kubectl is created, installed here. Now let's connect to the instance. And how do you connect to the instance? Well, I mentioned that part as well here. You just need to run this command, update the kubeconfig using the following command. You just copy it. Let me clear this part. And in the cluster name, you need to give the name of your cluster, which in my case is prod cluster, right? If I'm not wrong. Yeah, this is the one. I'll just run this command, and it says added new context. You can check the same using kubectl. Let me first add an alias so that it's easy for us to just write kubectl You can do the same using alias cube page equals to kubectl. Now you can write kubectl get nodes. It says error from the server, cannot list nodes in the API group, cannot read all nodes, only its nodes object. I'll tell you why we are getting this error. Meanwhile, just run this command first, kubectl get pods, and it says pod is also prohibited. And to show you why, I'll tell you the reason why it's not working. And the reason being, if you go to your EKS cluster and you go to the access part, you will see something called IAM access entries, and here we do not have permission for that role. So what we need to do is we need to create a new access entry here, select the IAM role, and select the IAM role which is being used by your EC2 instance, which in our case is this EKS node role. Alright, so we are not able to access the cluster because of the permissions. So what I'll do is I'll create a new role for EC2 instance. So let's head over to IAM. Go to the roles, click on create role, and for the service keep it as EC2 because we will be using this role with the EC2 instance. Go to the next part, and even if you don't need add any permissions here, it's fine, but still I'll just add EKS here, EKS cluster policy. Go to the next, give it a role, just give it a name. I'll name it kubectl instance role. Click on create role, and our role is created. Now we can attach this role to our EC2 instance. So go to the instance, select kubectl instance, actions, security, modify IAM role, and select the role that we just created, which is kubectl instance role. Click on update IAM role, and the IAM role is updated. Now we can add now we have to go to the EKS cluster, and I'll show you what's missing here. So if you go to your cluster and you go to the access tab, you'll see something called IAM access entries. So these are like authentication and authorization part of the EKS cluster. Click on create, select instance, just copy the role ARN that we created, which is kubectl instance role. I'll copy the profile ARN, I'll paste it here. For the type, just keep it as standard. Go to next, select policy, just right here you just need to select cluster admin policy here. So you'll have cluster level access here. For the access scope, keep it as cluster. Go to next and click on create. Alright, so access entry was successfully created. If you go to this access tab again, you can see the access entry exists here, which is this one, kubectl instance role. Now you can just refresh this part here. Let's switch to sudo kubectl get pods. Now you can just refresh this part here. Let's switch to sudo kubectl get pods. Alright, I think I will have to refresh. I will have to restart my instance. Reboot instance. Let's close all these unnecessary tabs. Alright, so my instance is in running state. I'll click on. Alright, so let's try to connect to our cluster again. Click on connect. Okay, so I'm connected to the instance. I'll switch to sudo, add an alias here, kubectl, and now I'll try to run the command kubectl get pods. You can see currently there are no pods running, and you can see the nodes as well. Right now I have two nodes which are attached to my EKS cluster. So we have created our cluster, we created the node groups, and we created the EC2 instance to connect to the cluster. Let's try to run a pod here. kubectl run demo. I'll use our favorite image, which is nginx, and the namespace is going to be default. Okay, so the pod is created. You can just run kubectl.pods, and it's in a container creating state. Alright, so now our pod is running. So we created the EKS cluster, we created the node groups, and we were able to connect to it. And by the way, you can see this node here in the EKS dashboard as well if you want. Just need to go to resources, go to pods, and search for demo. So this is the pod that we just created. Alright everyone, so this is all for this video. I hope you liked it, and if you liked it, just share it with other people so that other people can also benefit from this. In this next part of the video, we'll create this entire cluster using CloudFormation, so we don't have to do all this part. And by the way, now I'll be deleting this cluster, and you can do it too. Once you're done with your cluster, do not forget to delete it, otherwise you'll get charged for it.